When you're looking at two variables to determine if they are independent or dependent, you need to start with what types of variables they are, get it into the proper graphs to do some quick analysis, and then make a judgment call as to whether they appear independent or dependent. Now later on we're going to be able to get more precise with our judgments using hypothesis tests, and we'll be able to actually get a p-value, decide if we reject or not, and make some more objective decisions about independence versus dependence. But for now we're going to look just on the graphical side to have an intuitive sense for what we're going to be looking at later. So if we start out with some raw data here, here's some survey data. 5 questions that were asked. What is my GPA? How am I doing in this class? Whether I like to watch TV a lot, yes, or I do not, no. My gender, male or female, and how much I like chocolate on a scale of 1 to 5. So these are 5 questions that were on the survey, and it looks like there were 23 people that took the survey, all from a stats class. And if we look at this data, we can pick any 2 variables we want and try to see if there is a relationship between those variables. So if we start out, we have gender and how much I like chocolate. We could see if there is a relationship between gender and how much people enjoy chocolate. Now, gender is obviously a categorical variable, male or female. This one here, the chocolate from 1 to 5, we would consider that for our purposes to be quantitative. So that means that we are looking at a graph of 1 quantitative, 1 categorical. We click on it, and we're going to end up with the option between dot plots, histograms, and box plots. So we get our data, and we're going to copy and paste it, starting with the header, and we're going to edit our data here in StatKey, completely clear out everything inside, and paste in our new stuff. And if you paste it exactly as is, it should come out cleanly from a spreadsheet. You want to keep your header row always checked when you copy with the header. And here is our data. As a dot plot, you can see there's not a lot of data points, especially in the female section. So things are a little bit bunched up around the 4s. With the males, it appears that they are far more spread out. There are a lot of 4s, a lot of 5s, a few 3s, and then even a 2 and a 1. When we go to histogram, the histogram, depending on how you adjust your graph, will look a little bit different. So there's kind of a few different ways to view this. It's probably not the best graph when you have data separated at 1, 2, 3, 4, 5, and when you have so few data points. This kind of graph isn't a great visual. It's a lot better when you have a large amount of data. And then box plot. Now the box plot here is interesting because if you look at the females, their minimum, their quarter 1, their median, and their quarter 3 are all exactly the same. So this box is completely flat on itself. And because they're all the same, this single 5 is actually deemed an outlier. So not as useful of a graph. The males here, you can see this is a little bit more useful of a graph here. But if we go back to our dot plot, you can make some comparisons and say, if I knew that you were male, I would have a much harder time guessing how much you liked chocolate. I still might guess 4 as my best guess, but I would probably err a little bit on the lower end, and I would know that I have a better chance of being wrong in my guessing. If I knew you were female, I would probably just guess 4 because I'd have a pretty good chance of guessing correctly. So 4 out of 5 for how much you like chocolate. Another thing besides the visual is to look over here at the average and standard deviations. You can see that the female average is slightly higher than the males, but not very much. And the standard deviation is much higher for the males. You can see it's much more spread apart. The females are much closer to the average, much closer to each other. So if I were to make a judgment call on independence here, I would probably say that gender and how much you like chocolate are, based on this data, still considered fairly independent, as in there is not a relationship. And the reason I say that is because when we look at independence, we are usually focusing on the average or the middle. And for both of these, their middle is mostly the same. There's not a clear shift where all of the males or all of the females are higher. Are the distributions different? Yeah, the males are far more spread out. But when we talk about independence and dependence, we typically look at the middle on these kinds of graphs. So even with our box plot, our medians line up. The quarter 1 and quarter 3 are fairly equally spread. And then again with the dot plot, you can see that they both line up with the 4s. Go back to our data. If we were to ask a new question such as, does my GPA predict how I am doing in this class? If I knew your GPA ahead of time, would that help me be able to predict how you're going to be doing in this class by your own 1 to 5 rating? We have a number here and we have a number here. We have quantities for both, so we have 2 quantitative variables. And when we get to StatKey, we're going to select that. What we're looking for, if these variables are dependent, if they are related, dependent on each other, we expect to see a trend. Like the variables shown on the screen here, there appears to be a trend by default. So now let's paste in our data. Again, I brought the header row along and I kept that checked. And we have our trend line on here, and it looks like we have something going up. Now, how significant is that trend? Let's take a little bit of a closer look. We can see here that we have some points down here way off the path. We have some points over here way off the path. Not a ton of points necessarily directly on the path. One hint visually, if I take this off, I don't know that I could very easily draw that trend line if it wasn't drawn for me. So that's one hint that there's probably not a relationship. Another hint is to look at the correlation value. And when I see a correlation of 0.296, that to me sounds not very strong, not very convincing. So I'm thinking probably not a relationship that's worth talking about with such a low correlation. Based on all of that, my judgment call would be to say that the 2 variables are independent. They are not related. Just like the last one, another call for independence. Last thing that you can do is you can move around some 1 or 2 data points and just see how much that affects things. If moving 1 data point is very powerful as far as adjusting the trend, sometimes that can tell you that the trend is not as great as it sounds. So moving this 1 data point from here over to this side can completely change the slope. So that's not as convincing. Going back to our data here, if we were to ask another question, is there a relationship between gender and whether or not you like to watch a lot of TV? We can go ahead and copy these 2 categorical variables here into StatKey. Choose 2 categorical. And in categorical, you're going to end up with these stacked bar graphs here. So if we paste this in, when we're pasting from a spreadsheet, we want to make sure that we check raw data. And we do have a header row, so we can leave that checked as well. But we always want to check raw data when we come out of a spreadsheet. The way it was formatted previously, if we had maybe a table, a 2-way table that listed both of the variable options on each side and their intersections, we could fill it in like this. So we have our raw data, and then here we go. So we have a yes and a no column, and then we have females in brown and males in blue. So for people that seem to like watching TV, it seems like it's roughly half female and half male. For the people that answer no, I don't really like watching TV that much, it appears to be about 25 or less % female and a much higher % male. So a lot of males here are saying no, a very small number say yes, or females say no. About the same number of males and females said yes. Let's switch the variables around and look at it from a different perspective. Given that you are a female, it seems like there is 4 out of 7, a little more than half that say yes, I like watching TV, a little less than half that say no, I don't like it. For the males, 5 out of 16, so less than a third of the males say I like watching TV. Over 2/3 of the males say they do not. And if you go to the proportions here, you don't have to figure out all those calculations in your head. You can get those done for you. So if you look at from the row perspective here. Of the yeses, 44% are female. Of the females, 57% are yes. Of the males, 31% are yes. So depending on whether you choose row or column, there's different ways of breaking down these proportions. The key thing that you're looking for is that this total column and the males and females are all different. If you see that this is a large, or about half the females, and here it's only about a third of the males that say yes, you know that there's a difference. If I told you the gender of the person first, you would be able to make a better prediction of whether or not they are going to like watching TV. So knowing gender helps you predict whether they like watching TV. Therefore, we assume that there probably is dependence. There is a relationship, a connection, a link between these variables. So the first two we didn't see any real convincing relationship. Here it really appears that there is a convincing relationship, that females are more likely to enjoy watching TV than males based on these graphs.